Hey everyone, good evening. So welcome. So this is lecture number 7 of calculus. So in this class we're going to finish maxima and minima for functions of single variable. Then we'll also do some application problem based on maxima and minima for functions of single variable. Is my audio and video is clear, right? My audio and video is clear, right? So we'll start our session. So the topic that we're going to discuss is maxima and minima for function of single variable, right? So in the previous class, what we did is we have completed Lagrange's theorem, right? And that is in calculus 05, we have finished Rolle's theorem. Then in calculus 06, we have finished Lagrange's theorem, right? So in this class, we're going to do maxima minima for function of single variable. So still Taylor's theorem is pending, right? Still Taylor's theorem is pending. So Taylor's theorem and asymptote, that two I'll combine and take as one class. This class I'm going to concentrate only on maxima and minima for function of single variable, right? Okay. After the Taylor's theorem and asymptotes, we'll be moving on to functions of two variable. For two variable, we'll be finding limits, continuity, differentiability, and maximum minima for two multivariables, and then partial differentiation calculus will be completed. That is, differential calculus will be completed, right? Okay, so this is calculus 07. So I'll try to complete within calculus 0, calculus 13 or 14, right? So yes, so we'll start. So first, what we'll do is we will define. First, we'll introduce the concept of maxima and minima. So I'll go a little bit fast. Very interesting topic. Application problems will be very good. So maxima and minima. Maxima and minima for functions of single variable, right? That is f of x of single variable. Okay, so we'll start. So let us define a function f from R to R, right? Let us define a function f from R to R. That is our domain. That is real number to real number, right? We are defining a function f of x. Now I'm going to discuss about where this function has maximum, where this function has minimum, right? So what I'll do is let us consider the following graph, right? Let us consider the following graph. It goes like this. It goes like this. It goes like this. Then this, and then it goes on like this, right? Consider this following graph. Now you can see this function has many maxima and many minima in the neighborhood of some interval. For example, you can see this point, or else let us draw a graph like this. Okay. You can, when you consider this point is maximum point in this interval, right? If you consider this interval, then in this interval, our capital M1 is our maximum value. When you consider, again, this is also a maximum value when you consider this interval, right? When you consider this interval, this is also a maximum value. When you consider this interval, when you consider this interval, this is again a maximum value, right? When you consider this interval, this is one minimum value, right? I'll write it as small m1. When you consider this interval, this is one minimum value. Again, there is one minimum value, m2. So you can see in some neighborhood, let us say this point is some x1, and this point is x2, and this point is x3, and this point is x4, and this point is x5. You can see at the point x1, x2, x3, x4, x5, these 5 points produces either maxima or minima. Yes or no? These 5 points has maxima or minima in some neighborhood. When you consider throughout, you can see this has three maxima. This graph has three maxima. Out of all three maxima, which is maximum of all three, capital M1 is the maximum of all three. That is called global maximum. You can see this has minima. Yeah, small m1 is minima, small m2 is minima when you consider locally. Throughout This minima, which is minimum value. M1 is the minimum value. That we say that M1 is our global minimum value. But that we are not going to such that. So in some neighborhood, you can always think that the graph will have many maxima, many minima. Need not be. Some graph may have maxima, some graph need not have maxima. There are functions which neither has maxima nor minima. That we will not consider this, right? As of now, we'll stick to this. As of now, we can see that a graph may have many maxima, many minima. When I say maximum means at some interval, that point is maximum. You can see capital M1 is maximum in this interval. In this, that is x3, at x3 it attains maximum in the neighborhood of x3. And again, this x4 as maximum in the neighborhood of x4, M2 is maximum. But what you infer is even see, function may attain a maxima or function may attain minima. You can see at x1 it attains maximum. What about the derivative at x1? It will be 0, right? Derivative at x1 will be equal to 0, right? Why? Because you can see at x1 the tangent line is parallel to x-axis. So, if a tangent line is parallel to x-axis, slope will be equal to 0. And similarly, at x2 it attains minimum value. And again, you can see what is f dash of x2. What is f dash of x2? It is 0 again because this line is also parallel to x-axis. Tangent line is parallel to x-axis. And again, at m1, see, x3 takes m1 value. That means f dash of x3 will be equal to 0, right? And again, this is our maximum value. And again, f dash of x4 is equal to 0. And again, this point f dash of xy is equal to 0. So what we see is, if a function has either maxima or minima, at that point, your derivative will be equal to 0. Then only it will have either maxima or minima. So, in order to find maxima or minima, first you have to find all those points where your first derivative is equal to 0. The points where all the first derivatives are 0, that point is called critical point, we will say, right? Critical point, or f of x is not defined at that point also, it's a critical point. But first what you have to do is you have to find all those points where your f dash of x is equal to 0, right? And then step 1, so to find maxima or minima, step 1 is you find all x whose derivative is equal to 0, right? Whose derivative is equal to 0. That is, you are finding all those critical points, right? And step two is, see, we are finding all, now we have found all those points whose derivative is equal to 0. In this example, our points are x1, x2, x3, x4 and x5. Now we find f double dash of x, right? We have function f of x. Now you substitute, let us say these points are x is equal to some alpha I, right? We will get many values. In this graph, you can see there are 5 values, but depending upon the function, there will be many values, right? Let us say those points are x is equal to alpha I. Now we substitute every points in f double dash of let us say the x are, let us say the x are alpha 1, alpha 2 and so on, right? Let us say the alpha 1, alpha 2, alpha 3 be the roots of f dash of x equal to 0. Now you substitute all those points in f double dash. If f double dash of alpha I is less than 0, substitute this point in this alpha f double dash. If f double dash of alpha is less than 0, we say at x is equal to alpha I, it attains maximum value. It attains maximum. If f double dash of alpha I is greater than 0, we say at x is equal to alpha I, it attains minimum value, right? It attains minimum value. And what is our minimum value? F of alpha is our minimum value. F of alpha is the minimum value. right? And this f of alpha is our maximum value. Okay, what we are doing is, what is meant by increasing decreasing function, right? So after this, the function is decreasing. That means what? Derivative is less than 0. In the last class we have seen, right? Decreasing means derivative is less than 0. Increasing means derivative is greater than 0. So after this, our function is decreasing. So that means this is our f dash. So f dash is decreasing. F dash is decreasing means f double dash will be less than 0. That means this is our maximum value. That's it. I'll again repeat. This is our f dash. After this is decreasing. You see f dash as one function. F dash is decreasing. That means f dash of dash is less than 0. F dash of dash is f double dash. So f double dash is less than 0. So f double dash is less than 0. That means this point is maximum value. After this function is decreasing. When you have minimum value, after this function is increasing. This is f dash. After this, f dash is increasing. So f dash dash is greater than 0. That means f double dash is greater than 0. So we have whenever greater than 0 at a point means minimum, less than 0 at a point is minimum, maximum, right? Yes, so very simple. So we'll do some problems, then we will have a better idea, right? So find the these are just 12th standard level problem, right? So I'm not sticking to this, right? These are just 12th standard level problem. Find the maximum and the minimum, find the maximum and minimum value of the function 2x cube minus 9x square minus 24x minus 20 is equal to 0. Right? So we will do this solution. So first what we will do is we have a function f of x is 2x cube minus 9x square minus 24x minus 20. First what we will do is we will find all those points where derivative is 0. So what is f dash of x? So 2 into 3x square. So 9 into 2x. So 24 is equal to 0. So we have 6x square minus 18x minus 24 is equal to 0. So 6x square minus 3x minus 4 is equal to 0. This implies x square minus 3x minus 4 is equal to 0. So x is equal to minus b plus or minus root of b square minus 4ac whole divided by 2 times a. So we have 3 plus or minus 5 by 2. So 8 by 2 is 4 minus 2 by 2 is minus 1. So that means critical points are critical points are minus 1 and 4. That means that these are the 2 points where our slope is equal to 0. So either maxima or minima occurs only at this point, right? Now we have to say which is maximum, which we don't know. Now we will find f double dash of x. What is f double dash of x? D by dx of f dash of x. D by dx of what is f dash of x? This is our f dash of x, right? 6x square minus 18x minus 24. After the e getting 0, right? So what is what is the derivative of this? So 12x minus 18. So this is our f double dash. Now at x is equal to minus 1, what about f double dash of minus 1? What is f double dash of minus 1? 12 into minus 1 minus 18, which is less than 0. So that means at x is equal to minus 1, it attains maximum value, right? Whenever second derivative is less than 0, it attains maximum value. The maximum value is f of minus 1. So what is f of minus 1? You substitute in the question. So 2 into minus 1 whole cube, 9 into minus 1 whole square, 24 into minus 1 minus 20. So this is minus 2 minus 9 plus 24 minus 20. This will be 24 minus 20 is 4. 4 minus 11. So 4 minus 11. I think it is minus 7, right? So minus 7 is our minus 7 is our maximum value, right? Minus 7 is our maximum value. maximum value for this function. Now at x is equal to 4, now at x is equal to 4, what about f double dash of 4? F double dash of 4. So what is f double dash of x? 12x minus 18. So 12 into 4 minus 18, it is greater than 0. So that means at x is equal to 4, it attains minimum value. The minimum value is f of 4. Now what is f of 4? So 2 into 4 cube, 9 into 4 square, minus 24 into 4, minus 20. So 2 into 4 cube is 64, 4 square is 16, 24 into 4 is what? 80, 96 minus 20. This is 128 minus 16 nines are. So 16 nines are, I think, 144, right? Minus 96 minus 20. So 128 minus 144 minus 16 minus 16 minus 132. So that means minus 132 is our minimum value. Minimum value is minus 132 and the maximum value is minus 7. Right? Find the maximum value of the function. Find the maximum value of the function log x by x. X is greater than 0. We need to find the maximum value for this function, right? Okay. So we have a function f of x is given by log x by x. Now we will find f dash of x equal to 0. So we'll differentiate this. So this is u by v. So v into u dash minus u into v dash whole divided by v square is equal to 0. So x into derivative of log x is 1 by x minus log x derivative of x is 1 whole divided by v square is equal to 0. So that means 1 minus log x is equal to 0. Log x is equal to 1, right? So here we have base e. If a base is not mentioned, it is e. That means what? X is equal to e, right? When you put e only, log e will be equal to 1. Or you take e on both sides. Take e, raise e on both sides. So x is equal to e is our critical point. So that means either maxima or minima occurs only at e. But since we have only one point, either this will have maxima or will have minima. Because we have only one point for which f dash is equal to 0. Now we will find f double dash of x, right? So d by dx of f dash of x. So d by dx of what is f dash of x? This is our f dash of x, right? 1 minus log x by x square, right? 1 minus log x by x square is our f dash of x. Now we'll differentiate this once again. Minus log x by x. Okay. So we have d by dx of this. So we'll keep x square as it is. Derivative of this is minus 1 by x minus 1 minus log x into 2x v into u dash minus u into v dash whole divided by v square. V square is x power 4. It is x power 4. So this will be minus x minus 2x plus 2x log x whole divided by x power 4. So we have minus 3x plus 2x log x whole divided by x power 4, right? Minus 2x minus 3x plus 2 log x. So 1x I can cancel. So minus 3 plus 2 log x whole divided by x cube. This is our f double dash of x. Now what is f double dash of e? What is f double dash of e? Minus 3 plus 2 log e divided by e cube. So log e is 1, right? So we will have minus 1 by e cube, which is less than 0, right? Because e cube is, e value of e is 2.7 something. So this is less than 0. This implies at x is equal to e, it attains maximum value. The maximum value is given by what? Conclusion. What is our conclusion? Maximum value is f of e, because e it attains maximum value. Maximum value is f of e, which is log e by e. So 1 by e is our maximum value for this function, right? Okay. So if you want to find maximum minima, very simple. Find the roots of f dash of x. All the roots either will have maxima or minima. You substitute each root in f double dash. If f double dash is less than 0, it is maxima, greater than 0, minima. Very simple. Okay. That is 12th standard level problem. Problem number 3. Problem 3, I'm just going to give you int. After that, I'm going to do some application problem based on maxima and minima. Okay. So find the maximum and minimum. Find the maximum and minimum value of the function sin x plus sin 2x by 2 plus sin 3x by 3, where x lies between 0 to pi, right? Or x lies between 0 to pi. So similarly, you find f dash of x is equal to 0. So we have to find maximum minima on this interval only. F dash of x is equal to 0. So derivative of sin x is cos x plus 1 by 2. Derivative of sin 2x is cos 2x into 2 plus 1 by 3. Derivative of sin 3x cos 3x into 3 equal to 0. 2 2 will get cancelled. 3 3 will get cancelled. So we have cos x plus cos 2x plus cos 3x equal to 0. Now cos A plus cos B. So cos A plus cos B. What is cos A plus cos B? 2 cos A plus B by 2, cos A minus B by 2. So 2 cos A plus B by 2, cos A minus B by 2, right? That is cos A plus cos B. So what we'll do is, we will apply this formula for cos x plus cos 3x. Cos x plus cos 3x plus cos 2x is equal to 0. Cos x plus cos 3x. So 2 cos 2x cos x plus cos 2x is equal to 0. A plus b by 2, x plus 3x by 2, 4x by 2 is 2x. X minus 3x by 2 will be minus x. Cos of minus x is cos x, even function. Let's take cos x common. So we will have cos x plus 1 equal to 0. I'm finding roots of f dash, so that I'm just factorizing this. So that means cos 2x is equal to 0, or 2 cos x is equal to minus 1. So that means cos x is minus 1 by 2, or cos 2x is equal to 0. Now you have to find all those points where cos 2x is 0. You have to find all those points where cos 2x is 0. Right? Just a minute. Okay. See, you have to find only in this interval, right? 0 to pi. So in 0 to pi, where cos will be 0, cos x is 0 when x is pi by 2, right? Cos 2x is equal to 0 or cos x is equal to minus 1 by 2. Cos 2x is 0 when 2x is equal to pi by 2, right? When 2x equal to 0 to pi or what? Okay, so 0 to pi by 2, 3 pi by 2, right? Because at pi by 2 as well as 3 pi by 2, cos x will be 0. Just write draw the graph for 0, pi by 2, this pi or 2 pi, dx, okay, correct only. So when 2x is pi by 2, 3 pi by 2. When 2x is pi by 2, 3 pi by 2, our x will be in this interval, right? Even though 3 pi by 2 is not outside of x, but 2x is equal to pi by 2 or 3 pi by 2. So that means x is equal to pi by 4 or x is equal to 3 pi by 4. So at pi by 4, 3 pi by 4, both belongs to our domain. And you can see at pi by 4 and 3 pi by 4, cos x will be 0. So this gives two critical points. Again, when cos x is minus 1 by 2, so x takes pi by 4. So cos pi by 4 is, um, sorry, not pi by 4. It is, what is cos pi by 4? It is minus 1 by 2 or plus 1 by 2. A minute. I think I made some mistake. Uh, Not pi by 4, right? Sorry. It is 1 by root 2, right? Cos pi by. I think it is 2 pi by 3, right? Pi minus pi by 3. So pi minus pi by 3. So pi minus the second quadrant. So minus cos pi by 3. So minus cos pi by 3 cos 60, yes. 2 pi by 3. So this gives x equal to 2 pi by 3. This gives pi by 4, 3 pi by 4. So that means these are the points f dash of x equal to 0. This implies these are the critical points. Pi by 4, 3 pi by 4 and 2 pi by 3. Now you find f double dash of x. What is f double dash of x? D by dx of f dash of x. What is f dash of x? This is our f dash of x, right? What is our f dash of x? Cos x plus cos 2x plus cos 3x. Derivative of cos x is minus sin x. This is minus 2 sin 2x. This is minus 3 sin 2x, right? So if you take minus outside, we will have sin x plus 2 sin 2x plus 3 sin 3x. Now you just have to substitute this point here and then you find the value. Now I'll tell you, I'm not going to do this. At x is equal to pi by 4, f double dash of x, f double dash of x will be greater than 0. So that means at x is equal to pi by 4, it has minimum value. So minimum value is f of pi by 4. So what is f of pi by 4? You just substitute pi by 4 in the f of x, right? So very simple, you can do this. So, sorry, greater than 0, right? At pi by 4, sorry, at pi by 4, you will have, at pi by 4, you will have less than 0, I think. Yes. At pi by 4, your f double dash will be less than 0. That means f of pi by 4 will be maximum value. You substitute pi by 4, you will get the answer as 4 root 2 plus 3 by 6, right? And similarly, at x is equal to Similarly, at x is equal to 3 pi by 4, you just find f double dash of 3 pi by 4. Just substitute 3 pi by 4 here. All are very basic elementary maths. You can all you can find basic trigonometric values. So you will get f double dash of 3 pi by 4 as less than 0, right? Less than 0. So at x is equal to 3 pi by 4, it has maxima again. So again, maximum value is f of 3 pi by 4. So we'll get f of 3 pi by 4 as 4 root 2 minus 3 by 6. Just substitute 3 pi by 4 here, right? Okay. And again, at x is equal to 2 pi by 3, your f double dash of 2 pi by 3, you substitute 2 pi by 3 here. F double dash of 2 by 3 will be greater than 0. So that means you will have minimum value at 2 pi by 3. So you will get that value to be root 3 by 4. Right? All are very simple elementary maths that you can do in your. So find the maximum value, minimum value. So there are two maximum value. One is 4 root 2 plus 3 by 6 in some neighborhood. 4 root 2 minus 3 by 6 is also a maximum value in some neighborhood. And root 3 by 4 is the minimum value for this. So is this three problem clear for everyone? Uh, that is very simple. Just 12th standard level mathematics. If you want to find maxima minima, first derivative is equal to 0. Find all the roots. Substitute all the roots in f double dash. If f double dash is greater than 0, it will be minimum. If f double dash is less than 0, it will be maximum. Maximum value is f of that critical point. Right? Okay, so we'll move on to the next topic, which is application problems based on maxima and minima for function of single variable. So we're going to do some 5 to 7 application problems. So we'll do this very fast. It'll take time also. So let us do this fast. A minute. Just a minute. Just taking the questions. Is it clear up to now? Yes. So we'll start our first problem. So problem 1. Show that the maximum rectangle show that the maximum rectangle inscribed in a circle is a square, right? So that the maximum rectangle inscribed in a circle is a square. Okay, so we'll start our first problem. And see in the corner slide. What's the issue in the corner slide? I'll just move this. Just take a screenshot here. So first problem, just take a screenshot or else I'll share notes. I'll make sure that I'll not write in it. Okay, so show that the maximum rectangle inscribed in a circle is a square. So inside a circle, you need to inscribe a rectangle. So the area of that rectangle will be maximum if that rectangle is a square. That is what we're going to prove now. So what we are doing is we are inscribing a rectangle inside a square. We can inscribe many rectangles in this square, right? So we can inscribe many rectangle in this square. For example, you can see this is one rectangle, right? This is one rectangle. We can inscribe many rectangles inside this. Out of all these rectangle, uh, the one which has the largest area, that is maximum area, is the square, right? Is the square. Okay, so we'll prove this. Okay, so let x and y be the sides of a rectangle, right? So let x and y be the sides of a rectangle. Let us say we have a circle. This is our center, right? This is our center, and let us say a be the um, radius, right? Let us say a be the or else let us like this. Or else we'll keep as diameter. Okay. And let a be the diameter. Let a be the diameter of circle, right? So what we have is we have let x and y be the sides and a be the diameter. So that means this value is a, right? This full length is a because this is our center. So from center to this distance will be our a. We have so this is a right angle triangle, right? So let us call this square to be a b c d. So we have in triangle b d c, this right angle. You can apply Pythagoras theorem. X square plus y square is equal to a square. Call this as equation number 1, right? We have x square plus y square is equal to a square. Now what we need to do I need to maximize the rectangle, right? I need to maximize the rectangle. We need to maximize the rectangle. We need to maximize the rectangle. We need to maximize the area of rectangle, right? We need to maximize the area of rectangle. We need to maximize the area of rectangle. Now, what is area of rectangle? L into B. So, in our case, it is x into y. So, what is y? Y is root of a square minus x square, right? So, from here, y square is equal to a square minus x square. So, y will be root of. So, I need to maximize a. See, this x is greater than 0, right? Here, x is greater than 0, y is also greater than 0 because x and y are side length. So, we will maximize a square, right? This will be, we will maximize a square, which is x square minus a square, right? We will maximize a square, right? A will be, both are same only, right? We will maximize, right? So what we will do is x square plus y square is equal to a square. So it's x into what is y? I think we can do like, okay, I think we can do like this itself, right? A is maximum or see, A will be maximum or minimum. If A square is maximum, A will be maximum, right? If A square is minimum, A will be minimum because our x and y are greater than 0. That is in case. So we'll maximize this function, right? We will maximize this function. If this is maximum, A will be also maximum since x and y are greater than 0. So we will maximize this function because to find derivative, this is easy instead of this, right? We will maximize this function. Let us call this function to be some z, right? So we will maximize z. So what we have z, so z is x square into a square minus x square. See, in this z we have we brought all the equations together. Circle is of diameter a, and then we are maximizing this area of rectangle with respect to x square plus y square is equal to a square. That means inside this circle we are inscribing a rectangle. So both the equations came here, right? I'm using this area as L into B, and I'm using this y with the help of this constraint. That means we are getting both the constraints together in this equations. Okay. So we will maximize this. So dz by dx is equal to 0. What is dz by dx equal to 0? So we'll keep x square as it is. 0 minus 2x plus a square minus x square. Derivative of x square is 2x. So we have, what we'll do is, we'll just find the roots for this. So this is what, we'll take x common here, right? We will take x common here. So we will have minus 2x square plus a square minus x square is equal to 0. So minus 3x square plus a square is equal to 0. So 3x square is equal to a square. So 3x square is equal to, I made some mistake. Forgot this 2, right? So we will have minus 2x cube, 2x of a square minus x square is equal to 0. So we will cancel 1x. So we will have minus 2x square plus 2a square minus 2x square is equal to 0. So 2a square is equal to 4x square. So a square is equal to 2x square. That means x is equal to x square is equal to a square by 2. So that means x is equal to a by root 2, right? So we will take as positive because our x is greater than 0, right? So these are the critical point. So even though we have plus or minus a by root 2, since x is the side length, we will keep x as a by root. Now this will have either maxima or minima at x is equal to a by root 2. Now what is f double dash of x? That is f double dash of x. X is nothing but d double dash of z by, that is dz square by, that is z double dash, right? That is d by dx of, what is first derivative? First derivative is this, right? U into v dash, v into u dash. That is, our first derivative is minus 2x square plus 2a square minus 2x square. This is our first derivative, right? Minus 2x cube. What is our first derivative? This is our first derivative, right? This minus 2x cube plus 2x into a square minus 2x cube. So we'll differentiate this again. This is minus 2 into 3x square, which is minus 6x square, and this will be 2a square. This will be again minus 6x square. So I can write this as 12x square, right? Now at x is equal to a by root 2, what will happen to this z double dash? So minus 12 times x square is a square by 2 plus 2a square. So this is 6. You will have minus 4a square, right? Z double dash turns out to be minus 4a square. This is always less than 0, right? Because this is positive. This is positive. So minus into something is less than 0. So that means z double dash is less than 0 at x is equal to a by root 2. That means at x is equal to a by root 2, it has maximum value, right? So that means this will be maximum at x is equal to a by root 2. So what if x is equal to a by root 2? What about the value of y? X is a by root 2, right? What about the value of y? What about the value of y? So we have x square plus y square is equal to a square. So we know y is what? Root of a square minus x square. So root of a square minus x square is a square by 2. So 2a square minus a square. So again you will have y also to be a by root 2. Y also to be a by root 2. So both the sides are equal. X and y are the sides. And you can see both are equal to a by root 2. So this implies it is a square. That's it. It is a square because both the side length x and y are equal. This is the first problem is clear. The first problem is clear. To show that the maximum, see what I'm doing is you just inscribe a rectangle inside a circle. So we have a diameter to be a, x and y will be a side length. We need to prove this rectangle is a square. That means I need to prove x and y are equal. So I'm assuming this circle has a diameter a. So you find the relation x square plus y square is equal to a square. Call this as equation number 1. We need to maximize the area of this rectangle. This area of this rectangle is maximum when x takes the value a by root 2, right? So when x takes the value a by root 2, it has maximum value. So maximum value we have got the constraint. When x is a by root 2, both the sides are going to be equal. So maximum, see here we have got circle and rectangle both together in this equation, and then we have maximized this a to get the maximum value as a by root 2. At a by root 2, both the sides are equal, so therefore it is a square, right? On to the next problem. Problem number 2. Show that the semi vertical angle of the cone of maximum volume and of given slant height and of given slant height is tan inverse of root 2. So what we need to do is the cone will have a maximum value with a given slant height L when the semi-vertical angle is tan inverse of root 2, right? That's what this second problem is. So we'll prove this problem now. Possible to insert. Is it possible to insert cone? And write cones. Okay, not good. Okay, so we have a cone. Okay, so show that the semi-vertical angle. So this is called semi-vertical angle, right? This is called semi-vertical angle of a cone. Show the semi-vertical angle of a cone of maximum volume of given slant height. So this is our slant height L, right? This is our slant height L. So what we'll do is let alpha be the semi-vertical angle. Let alpha be the semi-vertical angle. Let alpha be the semi-vertical angle. Let us call this point to be O. Let us call this point to be A. Call this point to be C. Call this point to be C. Right? So they have you have given a cone with a slant height L, right? Slant height L. Yeah, you know the slant height, right? You know the slant height. So you know the slant height which is L. So they have given you a cone with a slant height, right? This is our slant height. So they have given you a cone with slant height L. That cone will have a maximum value when this angle is tan inverse of root 2. That's it. That is what we need to prove. You have given a cone with the slant height L, right? You need to show that this cone will have maximum value when this alpha is given by tan inverse of root 2. So let alpha be the semi-vertical angle. Let OA is equal to L be the slant height. Be the slant height, right? Now what we need to prove? I need to prove alpha is equal to tan inverse of root 2, right? Yes. We need to maximize what? We need to maximize the volume of cone. So we need to maximize the last problem. We need to maximize the area of rectangle. In this here, we need to maximize the volume of cone, right? The cone will have a maximum volume. So what is volume of cone? What is volume of cone? 1 by 3 of volume of cylinder is 1 by 3 of pi r square h, right? 1 by 3 of pi r square h. So 1 by 3 of pi times, see this is our r, right? This is our r, this is our h. Now how to represent this r and h in terms of alpha? This is L, this is a right angle triangle, right? This is L. So what about this distance? This distance is what? This distance is L times sine alpha, right? This distance is L times sine alpha, and this distance is L times cos alpha. Yes or no? See, what is sine alpha? What is sine alpha? AC by L. Yes or no? Opposite side by hypotenuse. Opposite side is AC. OA is our hypotenuse, which is L. So that means AC is equal to L sin alpha. And similarly, what is cos alpha? What is cos alpha? Adjacent by hypotenuse. Adjacent is OC. So OC by L. So OC is L cos alpha. AC is L sin alpha. So obviously this is our R. So that means this is L sin alpha whole square. Height is L cos alpha. Is it clear? This L sin alpha whole square to L cos alpha. So we have this is to be volume to be equal to pi by 3 L square sin square alpha, or else I can write L cube sin square alpha cos alpha. So pi by 3 L square, yeah, we need to maximize this volume, right? So first what we'll do is we will find critical points. So we need to show this as a maximum volume, and this maximum volume occurs when alpha is tan inverse of root 2. So what we'll do is we will find dV by d alpha is equal to 0, because v is a function of alpha here. So what is dV by d alpha? That is, we are finding first derivative is equal to 0. So pi L cube by 3 is constant. Pi L cube by 3 is constant. So we will keep sine square alpha as it is. Derivative of cos alpha is minus sine alpha, plus we will keep cos alpha as it is. Derivative of sine square alpha is 2 sine alpha cos alpha, right? 2 sine alpha, derivative of sine alpha is cos alpha, equal to 0. So we are equating this to 0. So what I can take common here? So pi L cube is not equal to 0. So this implies this term has to be 0. Which term? Sine minus sine cube alpha plus 2 sine alpha cos square alpha is equal to 0. So this implies if I take sine alpha outside, so minus sine square alpha plus 2 cos square alpha is equal to 0. This implies sine alpha is equal to 0, or minus sine square alpha plus 2 cos square alpha is 0. Sine alpha is 0 means alpha is 0, which is not possible, right? If alpha is 0, you will not have a cone. Yes or no? If this angle is 0, you will not have a cone. So this is not possible. This is not possible. This is not possible, right? So this is possible. That means sine square alpha is equal to 2 cos square alpha. Sine square alpha by cos square alpha is equal to 2. So tan square alpha is equal to 2. So that means tan alpha is equal to root 2, right? So alpha is what? Tan inverse of root 2. You will have plus or minus, again you will not have negative, right? Again you will not have negative. So that means when alpha is equal to tan inverse of root 2 is our critical point. We haven't showed that at this critical point our f double dash is less than 0. Then only this value will be maximum value, right? Now we will find v double dash, right? V double dash. So what is v dash? This is our v. This is our v dash, right? We will find v double dash. That is d by d alpha of minus sine cube alpha plus 2 sine alpha cos square alpha. You differentiate this, right? I think you do this. You differentiate this at x is equal to, sorry, you differentiate this to show that, and you differentiate this, and whenever, I think, but whenever you see sine square alpha, you substitute as 2 cos square alpha here, right? Whenever you see sine square alpha, you substitute 2 cos square alpha whenever here. At alpha is equal to tan inverse of root 2, you substitute this point here, or else you substitute whenever you see sine square alpha, you substitute this here. We see that v double dash will be less than 0. This implies at x is equal to alpha, sorry, at alpha is equal to, so that means at x is equal, that means Or else should I need to prove this? You can do this, right? Okay. You just show that this is less than 0. So that means at alpha is equal to tan inverse of root 2, it attains maximum, right? Hence the proof, hence the solution. So what we did is show that the semi-vertical angle of a cone of maximum volume. So we need to maximize the volume, and we shown that to maximum volume, the critical point turns out to be tan inverse of root 2. At tan inverse of root 2, you show the second derivative is less than 0. Obviously, it will be less than 0. You just substitute here, you show it is less than 0. At alpha is equal to tan inverse of root 2, it attains maximum value. That is what our next this problem is. So we'll move on to the next problem. Is these two problems are clear? Okay. On to the next thing. Is it clear up to now? Okay. We'll move on to the third problem. Same kind of problem. Problem 3. Show that show that the semi-vertical angle of the right circular cone of the given total surface and maximum volume is given by sine inverse of 1 by 3. See, this is alike to the previous problem. In the previous problem, they have given you a cone and they have given you a slant height. We shown that cone with a given slant height will have maximum volume when the semi-vertical angle is tan inverse of root 2. Here, they have given you a cone with the total surface area, that is CSA plus TSA. Sorry, CSA plus outer surface, that is TSA. Total surface area they have given. They have given you a cone with the total surface area. The previous problem, they have given you a cone with slant height. That cone will have maximum volume when the semi-vertical angle is tan inverse of root 2. Here, they have given you a cone with surface area of that cone. You know surface area of the cone. That cone will have maximum volume when the semi-vertical angle is sine inverse of 1 by 3. This is our question now. Right? Okay. We need to maximize the volume of cone. Surface area is known. The previous problem, slant height is known. That's the only difference. Okay. So we'll do this. Okay. So let x be the radius of cone. Let x be the radius of cone, h be the height and y be the slant height of a cone. Let h be the height and y be the slant height of the cone. Right? So we have this to be h, we have this to be h, we have this to be x, we have this to be y. What is the relation between x, y and h? Y square is equal to root of x square plus h square, right? Okay. Now, we know the total surface area, right? We know TSA of a cone. They have given the previous problem slant height is given. What is TSA of a cone? TSA plus this lower area. So CSA plus pi r square. Here our radius is x. That means what is our CSA of a cone? Pi rl plus pi r square. See, these are additional level problem. Pi r into L plus r, right? So pi r into L plus r is our TSA. That is CSA plus this lower circle. So in our case, our r is what? X. L is pi. What is r square? X square. So if I take pi x, if I take pi x outside, you will have, okay, let us keep this as it, pi x square plus pi, this is our CSA, and we know this is constant, right? And we know this is constant. This is a number. Let us try to differentiate this because we need this in the problem. Let us try to differentiate this, right? If I differentiate, what we will have? So if I differentiate this, pi x square derivative is 2x. If I differentiate this, we will keep x as it is. Derivative of x is dy by dx plus we will keep y as it is. Derivative of x is 1 equal to 0. Right? Differentiate this. We need this in the upcoming slide. In order to proceed this problem, we need this, right? So I'm differentiating this. This will be 0. Constant derivative is 0. I'm differentiating this. So derivative of pi x square is pi into 2x plus derivative of this is x into dy by dx plus y into x. So equal to 0. So I can cancel pi. So we have 2x plus x into dy by dx plus y is equal to 0. So x into dy by dx is equal to minus y minus 2x. Implies dy by dx is equal to minus y minus 2x divided by x. Right? Call this as equation number 1 because we need at this in some point of view. Minus y minus 2x by x. Call this as star. Yeah, as of now we haven't even started. As of now we know that TSA, I know that is a constant. So I'm differentiating this and I'm keeping dy by dx. Right? Now what we need to do, we need to maximize the volume of cone, right? Semi-vertical angle of right circular cone. Okay, we need to find the maximum volume. So what is volume of cone? What is volume of cone? 1 by 3 pi r square h. So 1 by 3 pi, our r is x square, height is h only. Height is h only. So we need to maximize this, right? So pi into x square. What is h? We know that x square plus y square is h square. So can I write h as root of x square plus y square? No, we need h only, right? Sorry. X square plus h square is equal to y square. So that means h is equal to root of y square minus x square. So instead of this h, I can write this as root of y square minus x square, right? This is our v. So what we'll do is instead of maximizing v, we will maximize v square, right? V square will be maximum. V square is maximum. We'll maximize v square. So 1 by 9 pi square x power 4 y square minus x square, right? V square maximum means will be maximum because all x y are greater than 0 here. Because in order to avoid this square root, I'm just squaring I'm just finding maximum value of v square. Okay, so 1 by 9 pi square x power 4 y square minus x square. We will maximize this, right? All this has some z. So we'll maximize this z. So pi square by 9 x power 4 y square minus x square. We'll maximize this function. So we'll find critical point. So for critical point dz by dx is equal to 0. See here we have two functions, right? X and as well as y. So pi square by 9 is constant. Let us keep this x power 4 as it is. Derivative of this is what? 2y dy by dx minus 2x. Now we'll keep y square minus x square. This derivative of x power 4 is 4x cube equal to 0. Is it clear? Just differentiating product rule. So pi square again I can neglect this. 1 x I can x cube I can take outside. So 1x will be here. So x into 2y dy by dx minus 2x square. 1x will be here. So x into this. And here we will have y square minus x square is equal to 0. I'm just trying to find the critical points, right? Okay. dz by dx equal to 0. Okay. Now, uh, now I'm going to substitute this dy by dx to be the star. I said right. We will be using dy by dx later. Okay. So before that, we will simplify this to some more extent. So 2xy dy by dx is equal to minus 2x square minus 3x square 3x square minus y. So we have 2xy. What is dy by dx? Minus y minus 2x by x minus y minus 2x by x is equal to 3x square minus y square. 1x will get cancelled. So 2y into y is minus 2y square. 2y into minus 2x is minus 4xy equal to 3x square minus y. What we have now? 4xy. Think I made. Everything is clear up to now. Is there any mistake I have made somewhere? Xy divided by dx is equal to. Okay, okay. Here I think it is y square. So we have 3x square minus y square minus 4xy is equal to 0. Can I write this as? Is it possible to write this as y minus 3x into y minus x? Factorize this. What you will have? Y minus 3x into y plus x. If you multiply this, what you will have? Y square, and here you will have plus xy, and here you will have minus 3xy, and here you will have minus 3x square. Yes, I can write like this, right? So this is nothing but this y minus 3x, y plus x. Or I can write this as y square plus 4xy minus 3x square is equal to 0. So y square some as 4x. Just a minute. 3xy Yes, I can write this. I can write like this. This is nothing but y minus 3x into y plus x if you do factorization. So that means y is equal to 3x or y is equal to minus x, right? This is not possible. This is not possible. Why? Just think of it, right? What is x and y here? All are distances. Um, so y is equal to 3x is our critical point, right? Is our critical point. Now, at y is equal to 3x, you just find second derivative, that is z double dash. So I think you can do this, right? You just differentiate this. Already we know z dash. You differentiate z double dash. You substitute y is equal to 3x. You'll be getting less than 0. So that means at y is equal to 3x, it will have it will have maximum value, right? At y is equal to 3x, it will have maximum value. So that means x by y is equal to 3, right? That means x by y is equal to 1 by 3, right? That means x by y is equal to 1 by 3. X by y is equal to 1 by 3. Now what is x by y? This is our semi-vertical angle alpha, right? Now what is sine alpha? What is sine alpha? Opposite by hypotenuse, x by y. So x by y I can write as sine alpha. So sine alpha is equal to 1 by 3 implies alpha is equal to sine inverse of 1 by 3. That's it. So when alpha takes the value sine inverse of 1 by 3, your will have a we will have a maximum value. This alone you take it as exercise, right? So alone you take it as exercise. That is, you differentiate this once again. You substitute y is equal to 3x. You show that all the value is less than 0. That's it. That is, a full value is less than 0. We can move on to next problem, right? Here the total surface area is given. That cone will have a maximum volume when the semi-vertical angle is sine inverse of 1 by 3, right? Okay. Okay, so we'll move on to the fourth problem. Is it clear up to now? Is these three problems are clear? We'll move on to problem number 4. So that so that the volume of greatest cylinder which can be which can be inscribed in a cone of height h and semi-vertical angle alpha is given by 4 by 27 pi h cube tan square alpha. So that the volume of reduced cylinder which can be inscribed in a cone of height h and semi-vertical angle alpha. See, what you have is you have a cone. Sorry, so that the volume of greatest cylinder. Okay, you have a cone inside cone you are inscribing a cylinder. For cylinder, you know the semi-vertical angle. Sorry, for cone, you know semi-vertical angle alpha and you know height of a cone, right? You are inscribing a cylinder inside the cone. For cone, you know semi-vertical angle which is alpha and height h. You need to show the volume of the greatest cylinder is given by 4 by 27 pi h cube tan square alpha, right? Okay. Okay, so we'll draw diagram so that you will have understood. So we'll start the problem. Okay, I think it's very easy problem. So I'll just give you a hint. You can do this. So we know the slant height. Sorry, we know the semi-vertical angle alpha and h be the height of the cone. They have given. We need to maximize the volume of cylinder, right? Okay. So let PQRS. So let PQRS be a cylinder. So let PQRS be a cylinder of radius x. So we have this to be x, right? Cylinder radius is x. So that they already mentioned here. This x. Okay. Let PQRS be a cylinder of radius x inscribed in the cone ABC of height h and semi-vertical angle alpha. And semi-vertical angle alpha, right? What we need to do, we need to maximize the volume of um, cylinder, right? We need to maximize the volume of cylinder. Okay. What we can do is we need to maximize the volume of cylinder. What is volume of cylinder? It is pi r square h, right? Pi r square h. But we don't know the height of the cylinder, right? This height is the height of the cylinder, but this height is the height of the cone. Don't think about differently, or else I'll write this as some capital H, right? So this is our capital H, right? This is our capital H. That is height of the cylinder. This is our capital H. This is our capital H. Now, how to find this capital H? We don't know, right? We don't know capital H, but I can find capital H. Now, what is AM actually? What is AM? You consider this right angle triangle. You consider this right angle triangle. This is x, right? This is radius of a cylinder. What is AM? What is tan alpha in the right angle triangle AMS? What is tan alpha actually? Opposite side by adjacent side. The opposite side is x, adjacent side is AM, right? AM. So that means AM is X tan alpha. Now what is capital H actually? Can I write capital H as total height is small h minus you remove AM. AM is X tan alpha. Is it clear? Is this clear? So our capital H is nothing but total height is small h. You remove AM, right? So this H is total height minus AM. So height of the cylinder is H minus X tan alpha, and the radius of cylinder is X. This will be pi x square. H is H minus X tan alpha. Is it clear up to now? So we need to maximize the volume of this, which is pi x square H minus X tan alpha. We need to maximize this function. So for maximize this function, we need to find the critical points first. So we will do dv by dx is equal to 0. So pi is constant. We will keep x square as it is. Derivative of this is what? Derivative of h is 0. Derivative of x is 1. So minus tan alpha. Okay. What I'll do is x square minus x. I think I did mistake. This cot alpha, right? AM is x by tan alpha actually. Sorry. AM is x by tan alpha. AM is x by tan alpha. That means AM is x cot alpha. Sorry. So this is cot x minus cot alpha. Right? Cot alpha. Sorry. So we need to maximize this. So we have this to be x minus cot alpha. Okay, now we will differentiate this. So dv by dx. So we'll keep x as square x square u into v dash. This is 0. This is minus 1. So we will have minus cot alpha. Now we'll keep h minus x cot alpha as it is. This derivative of x square is 2x equal to 0. So pi will be taken out. So minus x square cot alpha plus 2x into h minus x cot alpha is equal to 0. To cancel one x because x is not equal to 0, right? If x is equal to 0, we will not have cylinder, right? See, you can cancel this provided x is not equal to 0 only. So we will have minus cot alpha plus h minus x cot alpha is equal to 0, right? X minus h cot alpha is equal to 0. So that means what will be your x here? H equal. I think one x will be here. I think one x will be here. I think because we are removing only one x. This minus x. So this will be h minus 2x cot alpha is equal to 0. So h is equal to 2x cot alpha. So that means x is equal to making some mistakes. Why I'm doing this much of mistake? Sorry. I'm already multiplied 2 here, right? So 2h minus 2x cot alpha is equal to 0. So minus 3x cot alpha plus 2x is equal to 0. So 2h is equal to 3x cot alpha. So x is equal to 2h by 3 cot alpha or x is equal to 2h by 3 tan alpha. So 2h by 3 is our critical point, right? X is not equal to 0. Critical points are x is equal to 0 and x is equal to 2h by 3 tan alpha. Now we need to show at this point our cylinder is maximum. Now at x is equal to 2h by 3 tan alpha, we will find v double dash, right? we will find b double dash. I think you can do this, right? It is d by dx of b dash. What is d by dx of b dash? This is our d by dx of b dash, right? That is you have to differentiate pi x minus pi x square cot alpha plus 2x pi h minus x cot alpha. You differentiate this, very simple. At x is equal to 2h by 3 tan alpha, if when you differentiate and then substitute, you will get v double dash to be less than 0. That means at x is equal to 2h by 3 tan alpha, it attains maximum value, right? When x is equal to h by tan alpha, that is maximum value. So now what is the volume of cylinder? What we need to show that the volume of greatest cylinder is this. Now what is volume of cylinder? Pi r square h. So pi x square, in our case our height is capital H. And what is capital H? Capital H is, we know capital H is h minus x cot alpha. Now you substitute x is equal to this value. You substitute, I think I can use next page or else it will be confusing. Now what is volume of a cylinder? Pi r square capital H. Our r is x, capital H minus x cot alpha, I think, right? So x is 2h by 3 tan alpha, and then h minus x 2h by 3 tan alpha cot alpha. Just substitute x to be 2h by 3 tan alpha, right? Okay. So this will be I 2h by 3 tan alpha. This 2 will get cancelled, right? These 2 will get cancelled. So this will be 3h minus 2h will be h by 3. So I think we will get this, right? Okay, x square. So this is 4h square by 9 tan square alpha. This will be h by 3. So you will have 4 h cube by 9 into 3, 4 h cube by tan square alpha. So we have got the proof, right? So 4 h cube by 27, 4 h cube by 27, pi tan square alpha. So this is our volume of the cylinder. So what here is, we have given you a cone with height h and height small h and semi-vertical angle alpha. You need to show that the volume of the greatest cylinder that can be inscribed in this cone is nothing but pi 4 by 27 pi h cube tan square alpha, right? 4 by 27 pi h cube tan square alpha. This is what you need to prove. That is a volume of the greatest cylinder that can be inscribed in a cone. The semi-vertical angle alpha is known for the cone, and the height small h is also known for the cone, right? Is this four problems are clear? Is this four problems are clear? Okay, so move on to the next problem. This fifth problem. Problem number 5. so that so that the cone of greatest volume so that the cone of greatest volume which can be inscribed in a given sphere is such that three times its altitude, three times its altitude, three times its altitude is twice the diameter of sphere. Twice the diameter of the sphere. So that the cone of greatest volume which can be inscribed in a given sphere is such that three times its altitude is twice the diameter of the sphere. Okay, very simple again. I'll draw the diagram also. Let A be the radius of sphere, x be the radius of cone, y be the height of the cone. So what we are doing is we are inscribing a cone inside a sphere, right? We are inscribing a cone inside the sphere. Okay. So that the volume of greatest we need to show that the cone of greatest volume which can be inscribed in the given sphere is such that three times its altitude is twice the diameter of the sphere. So what I need to show three times its altitude. Height of the cone is y, right? Height of the cone is y. So that the cone of greatest volume which can be inscribed in a sphere is such that three times altitude twice the diameter of the sphere. Okay, twice the diameter of the sphere. So three times altitude is twice the diameter of the sphere. Twice the diameter of the sphere. So radius of the sphere is a. So diameter will be 2a. This is what we need to show, right? Three times the altitude of a cone is two times the diameter of the sphere. So show that the cone of greatest volume which can be inscribed. That means we need to maximize the volume of cone. So we will maximize the volume of cone. What is volume of cone? 1 by 3 of pi r square h. So 1 by 3 of pi. What is r? Radius of cone. Radius of cone is x. And what is the height of the cone? It is y, right? So pi x into pi x square into y. Now we will make this as a single variable. For that, what we will do is we will try to establish a relation between x, y, and a. We will try to establish a relation between this x, a, and y. What I can do? I can do is I can do is can I, we will try to establish a relation for OD here. Now can I write AD as can I write AD as can I write AD as um, can I write OD as can I write OD as AD minus OA? What is AD? AD is nothing but height of the cone. What is OA actually? Again, it is radius only, right? From center to any point of circumference of sphere. Again, it is radius. That means this OD is given by y minus a, right? OD is given by y minus a. So apply Pythagoras theorem for this right angle triangle. X square plus y minus a whole square is a square. That means I can write a square as x square as a square minus y minus a whole square. Is it clear? Else I'm making mistake. X square equal to a square means where is e square y? I think it is correct only. So that means I can write this as 1 by 3 pi x square as a square y minus a whole square into y. This is clear. I'm just trying to express this x in terms of y, right? Okay. So what is simplification of this? A square minus y square minus a square plus 2ay. These two will get cancelled. So our v will be equal to pi by 3 will be equal to pi by 3. Inside will be 2ay by 2ay minus y square and then multiplied by y. Right. Now what we'll do is for a maximum dv by dy is equal to 0. So just when you just differentiate this. So this is pi by 3 2a y square minus y cube. So differentiate this. So pi by 3 2a into 2y minus 3y square is equal to 0. So pi by 3 is not equal to 0. So 4ay minus 3y square is equal to 0. 1y we can cancel because y is not equal to 0. So 4a minus 3y is equal to 0. So 4a is equal to 3y. So that means when y is equal to 4a by 3, it will have maximum value. It's a critical point. Now you find a d square v by dx square. To differentiate this once again, what you will have? d by dx of pi by 3 4ay minus 3y square. To differentiate and substitute this at x at y is equal to at y is equal to at y is equal to 4a by 3, this d square v by dx square will be less than 0. This means at y is equal to 4a by 3, it has maximum value. That means 3y is equal to 2 into 2a. This is what we need to prove, right? 3 times of altitude is equal to 2 times diameter of earth. Hence the proof. Is it clear? So that the cone of greatest volume which can be inscribed in a sphere is such that 3 times altitude is twice the diameter of sphere. Okay, we'll move on to sixth problem. problem number 6. So that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius a is given by 2a by root 3. That's it. So that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius a is a 2a by root 3. Again, very simple problem. So we are inscribing a cylinder inside the sphere. How much that cylinder has to be of maximum volume? That happens when the height of the cylinder is 2a by root 3. When a is where a is the um, where a is the what radius of sphere. So this problem. Okay, so what we are doing is we are this is our center of the sphere, and this is a, right? This is our radius of cylinder, height of the cylinder. So what we need to prove is this height. This will be of maximum volume when height is 2a by root 3. This is what we need to prove, right? Okay, so we'll prove this. Let us call this. Let r be the radius of cylinder, right? Let r be the radius of cylinder and a be the radius of sphere. A be the radius of sphere, right? Okay. What we need to do? We need to maximize the volume of cylinder. Just a minute. We need to maximize the volume of cylinder. What is volume of cylinder? Pi r square h. So what is radius? Radius is r. So pi r square into h, right? Okay. So h is the height of the cylinder. H is the height of the cylinder. Okay. Let's call this point to be O. Call this point to be A. Let's call this point to be B. Let A, B, C, D be the cylinder, right? Let us call this point to be L. Let us call this point to be L. let OL is equal to x, right? Let OL is equal to x. This is a right angle triangle. So this is again R, right? So x square plus R square is A square, right? X square plus R square is A square, or else I can do like uh, we have we have x square plus R square is equal to A square. That means R square is A square minus x square, right? So from this right angle triangle, so I can write this as pi into R square is A square minus x square, and height of the cone is nothing but 2 times of OL, right? 2 times of OL. This is our height, so which is nothing but 2 times of OL, or else we'll also assume that H be the height of cylinder. H be height of cylinder. Okay, so this is pi times A square minus x square. OL is x. So we have done everything in terms of x, right? So 2 pi x into A square minus x square. We need to maximize this volume. So for that we have dv by dx is equal to 0. So 2 pi is constant. So we'll keep x as it is. Derivative of this is derivative of this is minus 2x plus we will keep A square minus x square as it is. Derivative of x is 1 equal to 0. So this means minus 2x square plus A square minus x square is 0. So we have minus 3x square plus A square is equal to 0. That means we have A square is equal to 3x square. That means x is equal to A by root 3. So when x is equal to A by root 3, uh, x is equal to A by root 3 is our critical point. Now at x is equal to A by root 3, we need to show this is our maximum. So for that we will find v double dash. So d by dx of v dash. What is v dash? 2 pi. This is what? Minus 2x square. And here 2 pi A square minus x square. You differentiate, and then at x is equal to A by root 3, this v double dash will be less than 0. That means at x is equal to A by root 3, it attains maximum value, right? So that means height, this will be what is the height of cylinder? It is h. What is h? H is 2 times of OL, right? H is 2 times of OL. What is OL? OL is x. What is x? A by root 3. So the cylinder will have a maximum volume when h is A by root 3. Hence the proof, right? Again, very interesting problem. So all these problems looks alike, right? So when you are studying, be careful. So we are going to do the final problem of today's class, uh, which is problem number 7, right? Okay, just a minute. Okay, so we'll move on to the last problem of today's class. Prove that the volume of the volume of the largest cone that can be inscribed. Prove that the volume of largest cone that can be inscribed in a sphere of radius r, let us say it is of radius r is 8 by 27 of the volume of sphere. Okay, so we'll do this and then we will wind off. We need to show that the volume of largest cone that can be inscribed in a sphere of radius r is 8 by 27 of volume of sphere, right? Okay, this is what we need to prove. So this will be the height of the cone. This will be the center of the sphere, and the sphere has radius capital R. Right? Okay, so we'll start here. So let OL is equal to x, right? Let us call this as this point as L, and call this point as A, call this point B, call this point as M, right? So let OL is equal to x. Okay. What we can have is now what we need to prove? We need to maximize the volume, right? We need to show that the volume rises to cone. We need to maximize the volume of cone. So what is volume of cone? Actually, what I need to prove is what I need to prove actually first. Volume of largest cone is equal to 8 by 27 of volume of sphere. This one I need to prove, right? What is volume of cone? 1 by 3 pi r square h. 8 by 27 of volume of sphere. So volume of sphere is for that what I can do is volume of sphere is what? Okay, volume of cone is what is volume of sphere? 4 by I think we can do this later on. So this one need to prove, right? We need to maximize the volume. So we will maximize the volume of cone. So what is volume of cone? 1 by 3 pi r square h. Now or else 1 by 3 pi times what is radius? Radius is al square. Height of the cone is lm, right? Lm. So we have pi by 3. Now what is al square? What is al square? Al square plus x square is equal to r square. That means al square is r square minus x square. So this is r square minus x square. And what about lm? Lm is the height of the cone, right? Lm is the height of the cone. What about this? This is also equal to r, right? Because from O to M is also radius. So x plus r. So r plus x is our Lm, right? L x. So we have volume of cone to be equal to pi by 3 r square minus x square r plus x. So we need to maximize this volume. So we will find dv by dx is equal to 0. So pi by 3 is constant. So we will keep r square minus x square as it is. Derivative of r plus x is 1. We will keep r plus x as it is. Derivative of this is minus 2x. equal to 0. So we have r square minus x square minus 2x into r plus x is equal to 0, right? R square minus x square. So this will be r square minus x square minus 2rx minus 2x square is equal to 0. You just have to solve for r and x, right? Uh, or else you can do like this. Or else you can do like this. R square minus x square I can write as r plus x into r minus x minus 2x into r plus x is equal to 0. R plus x I can take outside. So we will have r minus x minus 2. That means r is equal to minus x or r is equal to 3x. This is not possible because radius cannot be negative. That means when r is equal to 3x, it will have either maxima or minima, but we need to show it is maxima. Now you find d square v by dx square, that is d by dx of dv by dx. This is our dv by dx, right? This pi by 3 r square minus x square minus 2x into r plus x. Now you differentiate d by dx. To differentiate this, now at x is when r is equal to 3x, you differentiate and then you put r is equal to 3x or x is equal to r by 3, you will get d square v by dx square will be less than 0. That means at r is equal to 3x, that is when x is equal to r by 3, it has maximum value, right? When x is equal to r by 3, it will have maximum value, right? Okay. Now, what is the volume of cone? Now, what is the volume of cone? What is volume of cone? We have pi by 3 also star pi by 3 r square minus x square r plus x. Right now, you just substitute x is equal to r by 3. Just substitute x is equal to r by 3. The square is r square by 9 r plus r by 3. So we will have pi by 3 8 r square by 9 4 r by 3. So 8 by 27, 8 by 27, remaining what you will have 1 by 3 pi r cube, right? 4 by 3 pi r cube. Now what is actually 4 by 3 pi r cube? 4 by 3 pi r cube is nothing but volume of sphere, right? Because for sphere our radius is capital R. So we have shown that the volume of cone is 8 by 27 of volume of sphere, right? So very simple problem, very important problem also, the last problem. What is the volume of largest cone is in a sphere is given by 8 by 27 of volume of cone is of the inside the sphere is given by relation between the two volumes, right? 8 by 27 of volume of sphere. So that's it. So what we did in today's classes, we have started maxima and minima for a function of a single variable. We did some algebraic and some function based problem of proving of how to find maxima and minima. First problem, second problem, and then sine x, sine 2x, this problem, right? After that, we have started application problem. The application problem, we did 7 problems. So first problem is inside a sphere, we have inscribed uh, okay, inside a circle, we have inscribed the rectangle that will have a maximum area if that rectangle is a square, and then the cone, you want slant height of the cone. the semi-vertical angle, if tan inverse of root 2, then this cone will be, volume of cone will be maximum. If you know surface area of a cone, then that cone will be maximum when the semi-vertical angle, volume of cone will be maximum when the semi-vertical angle alpha is given by sin inverse of 1 by 3. And again, we are inscribing a cylinder inside a cone. For that cone, you know semi-vertical angle alpha and height h. Then this cone, sorry, this cylinder volume will be greatest if this pi by 27 pi s cube tan square alpha is the volume of greatest cylinder that can be inscribed in a cone. If you know the semi-vertical angle alpha, this can be also asked like find the volume of greatest cylinder which can be inscribed in a cone of height h and semi-vertical angle alpha. Instead of show that this, they ask like find the volume of greatest cylinder which can be inscribed in a cone of height h and a semi-vertical angle alpha. Right? You have to prove that it is equal to 4 by 27 pi h cube tan square alpha, and then 3 times its altitude is 2 times the diameter of the sphere. This kind of problem, and then we are inscribing a cylinder inside a sphere. What's the relation between this radius and the height? That height is given by 2a by root 3, maximum volume cylinder of height. And then last problem is volume of cone is 8 by 27 of volume of sphere of greatest volume. So that's it. So we'll wind off this class. So the next class start with the next concept, right? Thank you. All the best. Bye.